This week on Maths is Fun, I want to talk about some maths that's a little bit counterintuitive, but is absolutely correct. So here we've got a globe. Look at that, Shreya. So we have a bit of cable here that if I wrap around the globe, will be the circumference. So there it is. If we wrap that nicely around the globe, we'll see that fits, right? So I wrapped a cable around the Earth. Now, if I wanted this cable to hover 1 inch above the Earth, all I would need to do, roughly, is add 6 inches of cable, and then there you have it. I've got a cable that will wrap, that will be 1 inch above all the way around, if we could manage to hold it up. So here's where the bit comes in that doesn't sound very intuitive, because that's clear that I just added that much cable to this cable here, right? And we got it 1 inch around, 1 inch above the Earth. And you think to yourself, well, that seems right, given the size of that globe. Here's the trick. If I did the same thing with planet Earth, so imagine that I had a cable wrapped tightly around all of Earth. Now, Earth is about 24,900 miles around, huge. If I wrapped the cable tightly around that Earth, so my cable was 24,900 miles long, if I added just 6 inches to that cable, I would be able to lift that cable off the ground all the way around the Earth by just under 1 inch. It's actually 0.95 of an inch if you want to get precise, but roughly 1 inch. Or, let's look at it a bit different. This is a 6-foot cable here. If I added this 6-foot cable to my cable that is 24,900 miles long and wrapped it around the Earth, that cable would sit a whole foot above the Earth all the way around. So why does that work? That seems bananas, that a cable this long added to a cable that is 24,900 miles long would have the effect of lifting by a foot all the way around the Earth. That doesn't sound right, but it is, because maths. So how it works is this. The circumference is 2 times pi times the radius. So if you think about it then, the Earth's radius is 3,958 miles, give or take. And that's why when we times it by 2 pi, we get our circumference, which is 24,900. But if we add another bit of distance, if we say we wanted 1 more foot, well, if we took that 1 foot and times that by 2 pi and added that to the formula, you get a new number. So whatever you want to add, just times by 2 pi. Now, pi is 3.1415, whatever. Okay, big long number, but let's round it. Let's say it's 3.14. That means if I'm going to times something by 2, I'm going to times it by 6.28. So hence that if I take my 6 feet and I divide it by 2 pi, or 6.28, I'm left with just under 1 foot. So that's why the maths works. So in any object, it's the same. Whether you're talking about a globe, a basketball, a giant sphere, Earth, an entire galaxy, it doesn't matter. If you add something more, it will have the effect of making a bigger circle that is almost exactly 1/6 smaller than the bit you added. So in this instance, I added 6 inches to my cable, and that had the effect of adding 1 inch all the way around. If you had 6 feet, it would add just under 1 foot, and so on and so forth. Amazing.